Hello everyone, welcome to the world of data structures. Our today's topic is hashing, collision and collision resolution techniques in hashing. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, first today we are going to learn about how the collision works. What do we mean by collision? Then the types of collision resolution techniques like separate chaining, open addressing. In open addressing, we are going to see about the linear probing, quadratic probing and double hashing method. Okay, so let's start with the first, the collision. Students, what do we mean by the collision? See, if in hash function, if you apply the hash function on the key values and you get the hash index same as the previous, that means for two different keys you get a common hash value. Suppose if I apply hash function on 100 and I get answer 10. If I applied hash function on 200, again I get answer 10. That means the 10 place is already occupied by 100. Then it cannot be occupied by another value. So that situation is known as collision, when two keys result in a same hash value. The situation where the newly inserted key maps to an already occupied a slot in hash table, that is known as collision. Okay, so it must be handled by collision resolution techniques. But first understand the example of the collision. See, here my hash function is k, h of k is equal to k mod n. Okay, so what I need to do is, see, my hash function is very much common, k mod n. I usually prefer this only because it's very much easy to calculate the values from this function. Okay, so what I need to do is first h of k is equal to k mod n. Okay, let's take some data over here that I need to insert a values for n is equal to 11. So here the hash table size is 11. Okay, values like 21, 56, then 78, 133, 121 and 65. So if such these values if I want to insert in a table, then how can I insert it? Let's see. Just imagine this is my hash table. See, this is array, so I can represent it as a vertical or horizontal both form. Okay, so for my convenience I am just representing my array in a horizontal line where my index starts from 0 to 10. That shows total 11 size is there. For the first value 21, what I need to apply the hash function on for that. So h of 21 is equal to 21 modular 11. 21 modular 11 returns 10, so 21 should be inserted at 10th position. You can see over there in the figure. Now the next value is 56. So what do we need to apply? We need to apply h of 56. So 56 modular 11. 56 modular 11, that becomes 1 because 11 5s are 55. It returns only one remainder. So here it is, 56 is inserted at the first position. Now next we have 78. 78 is inserted at first again. Okay, how? Because 11 7s are 77. Okay, so it returns one value. So if for 78 I again get the hash value 1, if you can check in the figure, hash value 1 is already occupied by 56, so you cannot insert 78 over there. This situation is known as collision. Okay, so what to do with this? Let's see. So to remove this collision, we have some collision resolution techniques. Here we have, see, the collision resolution techniques further divided into two parts. The first method is separate chaining, where we are going to use the linked list, okay, for the same hash values. Then another method is open addressing, where the first method is linear probing, second is quadratic probing, and third one is double hashing. Okay, what you need to remember, you just need to remember how the method works and the formulas of all three methods. So formula for the linear probing is h of k comma I is equal to h dash of k plus I mod n. For quadratic probing, it is same as linear, but only instead of I need to write I square over there. And for double hashing, we have two different hash functions. Okay, like h dash of k plus h double dash of k into I mod n. Okay, so how this method works, let's understand directly with example. So just imagine a situation, students. The first method, that is separate chaining. This is my hash table. Okay, hash table size is 10, so I am representing with array 0 to 9 over there. My values that I want to insert like 20, 32, 41, 66, 72, 50, 106, 51 and 71. Okay. Hash function that I'm going to use is h of k is equal to k mod n. So let's start with the first value. First, if I want to insert 20, so 20 mod 10 becomes 0. So 20 should insert at 0th position like this. If you can see, I have inserted the 20 using linked list form because this is separate chaining. Chain, that means connection with each other in a chaining method. So each and every index shows a singly linked list. Okay, after 20 we do not have anything, that's why the 20th pointer is pointing to null. Fine. Now next value, students, we have 32. 32 modulo 10, that becomes 2. So we need to insert the 32 at the second position. So here it is. Next we have 41. So 41 modulo 10, that means 1. So we need to insert 41 at the first position. So here it is. Now next we have 66. 66 modulo 10, that becomes 6. So you can insert at the 6th position like this. Next we have 72. So students, 72 modulo 10, that becomes 2. Now if you can see the second position, we already have 32. So how to insert 72 over there? See, always remember, in collision resolution techniques, in separate chaining, the new value is inserted at the first position of the linked list. That's why first we have 72, then we have 32 like this. See, now there is no collision over there. You can insert n number of values at the second index. Okay, so whatever the key values that contains hash value 2, they all are getting inserted at the second position in separate chaining method. Now next we have 50. So 50 is also at 0, so you can insert like this 50. Fine. So this is the first method, that how can we resolve collision, that is known as separate chaining. It uses linked list, okay, to maintain the collision values. Okay, now next we have open addressing method. Students, in open addressing, instead of linked list, we are going to use a record in array, where each and every new entry has inserted the hash index of the hashed value computed with a new formula, and the array examined. If the place is available, then it is inserted over there. Okay. So what do we mean by probes? Why they are known as linear probing, quadratic probing? That we will understand soon. So let's see. The first method, students, we have linear probing. The formula for linear probing is h of k comma I is equal to h dash of k plus 1 mod n. Here h dash of k plus I mod n, where h dash of k is any hash function. But for my convenience, I am going to take a hash function like k mod n. Okay. So here I want to insert such type of values. Here I have values like 176, 75, 37, 56, 79, 158 and 10 and 99. Here n is equal to 10, that means hash table size is 10. Okay. So let's see. This is my hash table. Okay. For the first values 176, I need to apply, see, key and I is a probe. By default, for each and every key value, first I is 0. If collision occurs, then I is incremented. If collision occurs, then I is incremented. Then if we get another key value, then again I becomes 0. Let's see how. First I have h of k comma I, so I can write h of 176 comma 0. Need to apply the values over there. So h dash of k, the function is k mod n, that means 176 mod 10 plus, instead of I should write 0, then mod 10. So 6 plus 0 mod 10, 6 mod 10 becomes 6. So 176 inserted at the 6th position. Now next value, we have 75 with us. So again apply the formula. So 75 mod 10 plus 0, because I is 0. Okay. So 75 comma 0 is equal to 75 mod 10 plus 0 mod 10. Okay. So here the 5 plus 0, we get answer 5. So 75 is inserted at 5th position. Now next we have 37 with us. For 37 it goes same like previous two. So 37 mod 10 plus 0 mod 10, again we get the answer 7. So 37 is inserted at 7th position. Okay. So such like this you can insert your values. Now let me show you 56. See, for 56 I am just going to insert 56 comma 0, that returns 6. Now tell me, students, 56 comma 0 that returns 6, that means, but the 6 is already occupied by 176. This collision occurs. Collision occurs. So here what you need to do is, if the collision occurs, then you need to do a probing in a linear manner. That means if the I is 0, then you need to take I 1. Okay, so you need to again find out the values for this. So next value is 56, 1. 56, 1. Now I becomes 1. Okay, that is a change. Now I becomes 1, so we get the value 7. But 7 is already occupied. 37 is there. So you cannot insert 56 over there. So what to do? Just need to again increment I. So now your I becomes 2. So it is 56, 2. That is 56, 2. That becomes 8. So here your 56 is going to be inserted at 8th position. So here you can insert a 56 value at the 8th position. Okay, now let's see for the next values. Next value, students, we have 79. So 79, just apply the formula over there and you will get the answer 9. 9 is still occupied? No. So you can directly insert 79 over there. Fine. Now next we have 154. So just apply the values, formula for the 154. So 154 we get the answer 4. So we can insert 154 at 4th index. Now next we have 10. So 10, just apply the formula for 10. We get the answer 0. So we can insert 10 at 0th index. Now the last value is 99. So here for 99 students, first we have 99, 0, that we get 9, but 9 is already occupied. So what we need to do is we just need to increment I from 0 to 1. So we need to calculate 99, 1 over there. So here 99, 1, that becomes, see, 1. Now tell me, is one place is occupied? No, one is empty. So you can insert 99 at the first position. So this is how the linear probing works. Your probing means whenever the collision occurs, you are just incrementing the value of I. That incrementation of the value of I is in a linear fashion. That's why this example is known as linear probing. Now let's take out the next method where we have quadratic probing. See, the quadratic probing, the formula is similar as linear, but the change is little bit over there. Here I is incrementing in a quadratic fashion because it's not I, it's I square. Fine. So here we have for the 126, okay, n is 11. So my array is like this, hash table is like this. Now 126 mode 11 plus 0 square mode 11. 0 square becomes 0. Okay, 126 mode 11 becomes 5. So it's a 5 plus 0 mode 11, that means 5 again. So we can directly insert 126 over there. So 126 is inserted. Now next we have 75. So it goes like this. See, 75 mode 11. 75 mode 11 returns 9 and the calculation also returns 9. So after that we can insert 75 at 9th position. So here it is the 75 at the 9th position. Now for the 37, just apply the formula. Here we have 37 mode 11, that becomes 4. So after all the computation we get the answer 4. So 37 is inserted at the 4th position, students. Now we have 56 with us. 56. Students, the 56 that returns 1. After applying 56 that returns 1. So we can insert the data at the 1. So here I can insert directly 56 at first position. Now we have 29. So the answer of the 29 is 7. So we can insert the directly data at 7th index. Okay. Now next we have 154. So 154 we have 0. Is there any place empty for 154? Yes. 0 index is empty. So we can insert 154 at 0. Now for 10 we can insert directly 10 at 10th position. Now last value, that is 99. So here we have 99 students with us. So 99 mode 11, that becomes 0. Okay, but 0 index is already filled up. 0 position is not empty. So what you need to do is you just need to increment I from 0 to 1. So that becomes 99 mode 11 plus 1 square. See, instead of 0 square now it becomes 1 square. So here it is. The answer is 1. But now 1 is also occupied. So you need to increment I again. That becomes 2 square. So 99 mode 11 plus 2 square, that becomes 4. But 4 place is already occupied. So what to do? We need to again start with 3. So 3 square, that becomes 9. But 9 is already occupied. So go with again increment I, that becomes 4. So here it is, that becomes 16. 16 mod 11, that becomes 5. Is 5 occupied? Yes, 5 is occupied. So we need to again take another chance to increment I. That's a 5. So 25 mod 11, that becomes 3. 3 is empty, so I can insert 99 at my third index. Fine. Such like this the quadratic probing works. Now let's see the last method, that is known as double hashing. You just need to think about the formulas only. Okay. So here we have the double hashing method where h of k comma I is equal to h dash of k plus I into h double dash of k. So here you need to find out the hash value 2 times. H dash of k is a one function, h double dash of k is another function. That's why it's known as double hashing. But little bit twist over there, that the in h dash of k n value, that means that here the table size is 13. So for h double dash k you need to take the table size lesser than 13, smaller than 13. But it must be a prime value, that's why I need to take 11 over there. Okay. So here my n is 13 and dash is 11. Okay. So let's start the insertion process. For the 126, okay, when I'm applying the values goes like this. 126 comma 0 is equal to 126 mod 13 plus I is 0. So 0 into 126 mod 11. 126 mod 11. This 126 mod 11 is your h double dash k. Bracket complete, and the last time we have mod 13 with us. That returns the answer 9. So 126 inserted at the 9th position. Now we have 75 with us. That returns 5. It inserted 5th position. Now next we have 37. 37 returns 2. That means 37 is inserted at 2nd position. Now next we have 56 with us. 56 returns 4. So 56 inserted at the 4th position. Now next we have 29. See, 29 returns 2. 29 returns 2. That means here 2nd position is already occupied by 37. So you cannot insert 29 over there. So you need to increment your I. So here my I is incremented from 0 to 1. So 2 is occupied by that place. That's why I becomes 1. So here my next formula is 1 into 29 mod 11. See, the 29 mod 13 becomes 2. 29 mod 11 becomes 7. So it goes like 9 mod 13. That becomes 9 again. But the 9 place is already occupied. So I need to increment I again. That becomes 2. So 2 into 29 mod 11, that becomes 14. 7 into 2 becomes 14. So we get answer 16. 16 mod 13, answer is 3. 3 is not occupied. That's why I can insert 29 at 3rd position. Now the last value we have 152. So I can insert 152 at 11th position. Okay. So these are the techniques for the collision resolution. Today we have seen about the hashing methods, hash functions, then collision, and the last topic is collision resolution techniques. Okay. So that's it for today's lecture, students. Thank you so much.